Now, before I get started on projects, I usually do some field research so I don't have to reinvent the wheel, get some inspiration from other people and see how they tackled the issue. Like some of you out there, and perhaps you're even watching, are the engineering kind of people that aren't afraid to go use some exotic tools. They have a nice working shed that they can use with, I don't know, a CNC router, metal working tools. They over-engineer every project, think it's really true to every detail, so it mimics the real life deal. Well, today, that's not what I will be doing. I will be looking at the basics of an A320 speed brake and how we can code our own, create our own in Microsoft Flight Sim 2020. Now, how long will it take you to get started creating your own speed brake? Well, the coding, it's only going to take you a few minutes. I will explain it all, go through it step by step so you know what to deal with. You can print your own enclosure. I did mine in 3 to 4 hours, but it's just waiting time. So does it really count? And there's some really small part in the wiring, setting everything up, installing the software you need, and you're good to go. So all in all, if you work really efficient, you could do this in 10 minutes if you don't count the printing time. And I'm going to show you how. And before we get started, let's do the part that requires some physical, like sawing off a proper length of pipe that we're going to be using for the handle. Now it's going to be around the length of 45 millimeters. And this is a hollow aluminium kind of tube. It's very lightweight, it's hollow, so it saws quite easily with an iron saw. You don't need any fancy equipment or spend days sawing it through. I've printed this little connector. It connects directly onto a potentiometer like this. It requires quite some force. And on the top part, we could just enter the little iron bar. Now, why do we need the hollow bar? As you can see, the iron bar is way too heavy if it's filled in with, I don't know, I think it's steel, not quite sure, but it will just fall over. Like if we take an iron bar, the potentiometer itself will stay quite in place if we add some weight. Now, the moment we add the knob to it, even though it's plastic and very light, it will become quite top heavy, so it will still push the potentiometer down. Now, to counteract this, I've created a little contraption inside this box with these rubber spaces. I believe they are O-rings for plumbing usually. They come in all kinds of sizes. So what I've done is I've taken a smaller piece of steel, I believe it is. I'm not quite sure actually. That I've cut up to length. The other end of where the opposing end of the potentiometer has a little hole in it where we can plug it in, and this will also ensure that the handle stays centered in the box so it doesn't fall over because of the weight or anything. And because those 4 little rubber grommets are a little bit larger than the box itself, it will apply a minor amount of friction and tension. And as you might be able to tell, well, it's quite hard to do it by hand, but it will keep the rod in place. So now we've counteracted that top weight a little bit by applying some pressure on the lower part. As you're able to tell, it stays in place pretty good. You don't have to worry about it falling if you don't want to, or if you're mid-air, you don't want the handle to go fully open, your speed brake will be extended, etc. So all in all, it's a nifty, small, tiny device, but I love it. So we add some wiring. I'm not quite, it's very hard to see, but it's wired to the A0, ground and 5 volts, but I'll show you that in a second. And last but not least, we just connected it over USB. And there you go. That's how you can create your very own speed brake. Now, let me show you in FritzSync how it's wired up. It's really simple. We only got 2 moving parts. We got the Arduino and we got the potentiometer. Potentiometer has 3 pins. The middle pin is going to be used to measure the analog signal. So in our case, it's going to be A0 where it's going to be connected to. You could use any A pin. Just make sure that if you use a different pin than A0, that if you copy my code, that you actually change the pin number. The other pins, so the left and right pin, are hooked up to 5 volts and ground. Now, if you flip those two wires around, the left side will either be the max value or the right side will either be the max value, depending on where the power comes in or goes out, etc. And that's it. Just plug in a USB cable over here, the top part, and you should be good to go. So I had to make a few changes to the connector, the library, and as well to the WASM module. So if you want to use this, go download the latest version on the Bits and Droids website from bitsandroids.com/downloads, and I'll put a link in the description as well as the code to this video can be found in an article that will be in the description as well. A potentiometer is a variable resistance that come in all shapes and sizes, but these with those 3 pins and the brownish bottom, the cheapest ones out there, are the most common ones you'll find in any starter kits, or that you can buy relatively cheap from AliExpress, Amazon, whatever you want to. Now, a variable resistance, well, the name gives it away a little bit. So the more we open it, the more power can run through. The more we close it, the more the connection gets pinched off. Now, they also come in different resistances. So this is a 1K resistor. So fully open, it's at 0K. If it's fully closed, it's at 1K resistance. Now, the ones that we want to use are going to be 10K resistors. They are the most used ones. They're available everywhere. And I'll also put them in some affiliate links in the description. If you want to help the channel out, go buy them over there. But back to basics. Now, the reason you see this thing jumping all over the place is because the cables aren't plugged in towards the speed brake that we've created. So, but that doesn't take away what I'm trying to convey here. We got variable resistance. So the power changes depending on how far it's open and closed. If we look at our speed brake, what do we want to do? We want to match the in-game position of the lever. So a certain position on the resistance scale. And we want to match it on the other side with a certain position on our potentiometer as well. So we have a starting point. We have an end point. Now, a potentiometer can rotate somewhere around the scale of 320 degrees. But clearly we don't want our speed brake to rotate at an angle of 320 degrees as well. So we gotta do something that we take the value that it's currently at positioned, map it to a minimum value and a max value of the range that we have available, and then map that to the axis in game. Sounds complicated, but what it comes down to is that we have a min scale, where it's gonna be a value of 0, no power runs through. We have a maximum scale, where all power could run through freely, and that will return as a value of 1023. That's the way an Arduino converts the analog signal, so how many power runs through it, to a digital signal. It's on a scale of 0 to 1 and 2, 3. We gotta open it and we gotta close it, and I gave it away kind of. We have an analog signal and a digital signal. A digital signal are ones and zeros, like you've seen it in hacker movies. Ones and zeros, binary. It's the real basics of what computer works on. And we got an analog signal, which is a kind of wave. It increases, decreases. And we can even visualize it without a computer with an analog, how do you call it? I forgot the word. Doesn't matter. With the thing where you hook the power to and then you see the line go wee wee. Oscilloscope. Thank you very much. So there are all kinds of possibilities to measure an analog signal as well, without having to convert it to ones and zeros. But in our case, in Arduino, we want to convert it to ones and zeros. So if we start looking at our code, there are some basics that we need to do. We have a setup block. The code we put in here only runs when we power the Arduino. So it runs once, and then it will keep repeating the loop block. Like if you reset the board, it will call the setup block, keep looping until you reset the board again. It will call the setup block once, keep on looping in the loop block. So the real basics. So code we put in here runs once, code we put in here runs continuously until we power down the device, or we put some kind of logic in there to stop it. Now, at the very top of our file, we're going to be including our library. Hashtag include bits and droids flight connector.h. There we go. Basically, a library is a library full of code. So all the code you see on here, so it's quite large. It's thousands of lines. There are multiple files even, so more than 1,000 lines of code have been included in your code right now by just including one line. I did some of the groundwork for formatting strings, getting proper readings from an analog device, so as a potentiometer, so you don't have to reinvent the wheel. We can just do hashtag include bits and droids flight connector. It imports the code, and then we can call the code that's in there with all the functions that we basically need. So what do we want to do? We got a potentiometer that's hooked up to our Arduino. Where is it hooked up? Well, I hooked it up to pin A0. So let's first start out by defining where it's hooked up. So we say const bytes. Let's say speed break pin. It's always nice to have words that you can recognize. So later on, if I open the code again, I know this is the pin where the speed break is connected. If I hook up more components to the same board, because why not? You don't have to have a separate Arduino for everything. You can just have one Arduino that does multiple things. Now the potentiometer is an analog signal. We already know that. And how do we read an analog signal or get the digital version of it, the value? We're going to be using analog read. So it's going to read the state of speed break pin, and it's going to print it out because I said serial.println analog read speed break pin. Adding a little delay or else you're going to get hammered with values. And basically, if I already upload this, we should get some information back if we wire everything up. Make sure that you close all serial connections when you try to upload code or else it doesn't work. Now I heard the ping, so probably it is working right now. Now we just added 1, 2, 3 lines of code. I can hit the serial monitor button. Oh, I'm watching the wrong device. 711, 567, 793. So we see that the value changes depending on how far we open or close the device. Now my code, I've got the wires on backwards because the rest of my code, I'm going to cheat a little bit. So I've got to flip them around. Now we've got a range of 377-ish to, oh, this thing keeps moving around, to 190, which isn't correct. I need to tighten up the bolt on the... Sorry, I had to tighten it a little bit because it was moving around all over the place. But right now, if we open it fully, we get a range of... Oh my... Get a range of... Move it a little bit further. 30. Perfect. No, it's a little bit too low, I think, even. Doesn't matter. 45. And if you fully open it, it's going to be 320. So that tells us that if you have a range... Like if you could use the full range of the potentiometer, we would have 0 to 1 to 3. So this tells us that we are only utilizing, what did we say, 30, so 318. So that's 300 on a scale of 1 to 3, about 1/3 of the potentiometer. You see that it's quite jittery, right? Right now you can see that it sometimes jumps 6.4, 6.5, 6.4, 6.5. A cheap potentiometer can get affected by so many things. The power delivery to the board could cause a fluctuation in power read by the potentiometer. There could be dust in the potentiometer. It could move a little bit because of the weight, etc. So we want to smoothen out the readings a little bit. Now we could create our own function that does the smoothing for us, but luckily in the library there is already a function that does this for us. So I'm going to say bits and droids flight connector. I'm going to call the object a connector, and I'm going to say is equal to a bits and droids flight connector. Now, instead of analog read, we're going to say connector.smoothPot. It's going to smoothen the reading of the potentiometer and return a value based on the smoothened out reading. I believe it's with a capital P though. Here we go. Now we have the serial monitor. Not much is going to change, I think. Here we go, 6564, which means there is still some jitter on there. Now we could go even further, and this is something that we actually need to do. Right now it prints every value every time it reads it. But we don't want that. We want to overflood the connector with useless data, because why send over and over again that it's in the position when it's already in there? To do this, we need to have a variable that is going to store the old state. So let's say a reading of 238. Then in the loop, we check if the current reading is equal to 238. If that is the case, we don't send anything. If 238 is different than the value that is currently reading, we want to send a new value. Then store that new value at the old value's position, and we restart the loop. So instead of just printing it, we're going to create a variable. And we're going to make an int, because it's going to be of a scale of 0 to 1 or 2, 3. So an integer is a non-decimal value. So I would recommend to use names that you can easily recognize. Alt break position. We don't have to assign it a value. Now we create an integer in here that we call current break position. It's going to be equal to connector.smoothport speed break pin. Now if the current break position is not equal to the old break position, this exclamation mark and the equal signs just tells us is not. So if this is not equal to the old break position. So if they are different, we want to store the new value in the old break position. Old break position is equal to current break position. I make some typos along the way. Position. Here we go. Right here, you can see that it's fairly stable. The problem is that there is still quite some weight on the shaft, and it's just the potentiometer that holds it up. So we see that it doesn't keep flooding in, but it can still jitter a little bit up and down. Now, if you want to avoid the jitters, it's very much possible, because what is happening in the jitter? We notice that it jumps by 1, so 5.5 and 5.4. It doesn't really jump 3 at a time, 4 at a time. So what we could do is just check if the difference between the current break position and the old break position is bigger or equal than 2. So that will remove all the jitter, and only if we move it a little bit further, so we know that we really have a movement going, we can send the new data. Right now we say if it's not equal, but what we want to do is ABS. Now what does ABS mean? It means absolute. So even if we get a negative result, it will just give us the difference. So if it's a difference of -2, it will be 2, a difference of 2. And if we have +2, it will be 2 as well. So we're going to say if the current break position minus the old break position is bigger or equal than 2. So if that's the case, store the value, print the value, and that should eliminate most of the jitter. It's a real monitor. Here we go. Now nothing is being printed, so that's a good sign actually. If we move it, it changes with intervals of 2, because we said if it's bigger or equal to 2. And if we close it, we see it changes as well, but the jitter is gone. It just gave us less of a range. Now we are just printing the position right now. We're not giving it a value or prefix. We're not telling the game which command it's receiving. It just receives something. So in this case, the command for the speed break is 3000. Plus, we want to pass this as a string. There are other ways for this as well that are more clean than this one, but this will work for now. So we're going to say upload. It's important to add the space behind the 3000. I'm going to show you why in a second. Here we go. So now the connector is connected. It sends 3000 space the value. And if we now move it, we'll see that we can control it. And even if we move it a little bit, it's still moving. But we lost half of the range. So if you have a bigger construction than this miniature version, this might even be less of an impact because you have more room to work with. It's up to you how you want to do that. For me, this worked fine. Now, if we would remove that filter, so let's try that as well, so you can see the difference. Like, we can see that it's a little bit smoother, but I'm not really sure if I notice a difference. In theory, you could smoothen it out even more by using the full range, by using gears or over-engineered constructions like I saw you in the intro. Like, right now the limitation of the precision that we have is the construction that we are using. We're using a miniature version with a very limited range. And that is why the solutions you see out there usually have those over-engineered constructions. Over-engineered isn't a bad thing in my opinion, but they are a little bit more advanced than just a potentiometer that gets pushed up and down. They usually use gears or something else to increase the range, to use the full range of the potentiometer. So you can move the arm only a fraction, but the potentiometer moves like a bigger part. And that way, the more steps you have in between, the smoother the movement will be, the smoother the action will be in game, etc. So it's always a matter of how much time do you want to invest versus what's the result you're looking for. Now, but how does the connector know that we have only a limited range? Well, if you've installed the connector, you've installed the WASM module properly. So just place a folder inside the community folder. If you have the Microsoft Store version, you can just open the connector, hit WASM, install WASM, and it will just ship out and install it for you. Now, if you've done that, you'll find that in the community folder of Microsoft Flight Sim, there's a folder called Bits and Droids module. You hit modules, and there is a file named events. Okay, here we go. We have the axis spoiler set command. So it sets the axis spoiler, and you see a negative sign and a plus sign. The negative sign is my minus value, so minus 55. And my maximum value is 329. And if I would have a different range, like if I looked, where is it? Like if I flip my potentiometer around, here we go. Right now the readings will be flipped as well, so we use the other range of the potentiometer, which goes from 980 towards 703. Which should work fine, but if I now start the connector, so close first, always make sure that you close the serial monitor when you do this. So now I start the connector, and it should be stuck at max because the values we are passing is way above 500 or 300 we set as max. So in this case we could do, I believe it was 930 maximum and I don't know, 700. It doesn't really matter, it's just WASM update event file. Here we go. And now we should be able Now here is what I was talking about with the gears. You can clearly see that the movement of the shaft gets translated into a certain gear ratio that corresponds with a certain ratio on the potentiometer. So that is why, so that's the difference between both approaches. Now I had to restart the game because I had a little bug in there. That is now fixed, so that is coming your way as well. Now how to set up the connector. we're just gonna send something. So the only thing that you have to do is download the connector, extract the zip file, and there is an exe. You run it, you see this window. In here, you'll see the input mode. So we send data from our Arduino to the game. So we input data. Output mode would be if we only receive data from the game towards our board. And dual mode would be if we want to send and receive data from and towards the game with one Arduino. In our case, we just want to send something. So we use the input mode. And I've got it connected to COM port 3. So you just have a drop down with all your devices connected that it recognizes on a COM port. I've got my throttle somewhere connected, and this is a Leonardo, which we will be using. It will be stopped, you hit start. Right now the boards are green, so that means we have a connection to the board. If this is red, so it can't connect to the board, make sure that you check if you don't have the serial monitor open, because if that's the case, it can't send or receive data towards the game as well. Okay, so what we've done is we've changed the position of the cables. Now the max value is on the right side instead of the left side, etc. And we now have a range of 700 up until 964, which is fine. We went to the events text file that's in the module of the WASM, so in the community folder, bits and droids, modules, events.txt. The last line, because it's the last command that I've added, it's going to be the access spoiler set. Here we have the minus sign with the minimum value, so in 700, and the plus sign with the maximum value. Change this, hit save. If the connector is running, so in this case right now, update event file, and it should update the values as well. Here we go. So don't forget to add, change that for your specific setup, whatever your range is, to match. Now, right now we've got a different plane, same principle, speed brake. If we open or close ours, oh, it's reversed, so I had to flip the. So right now when it's open physically, if I close it, we move this around. You see that it's actually quite smooth, even though we have quite a limited range available. It automatically does that little thingy where it goes in. You can pull it out. You can do all kinds of crazy stuff with it, whatever you want. So yeah, that's basically it. Like, where I want to steer this channel to is towards more content like this, a small version that explains the basics, so you can get started without having that feeling like, oh, whatever he made is cool, but I'm never able to do that. That is something that I struggled with in the beginning. I watched the tutorial and I'm like, that's a very complicated project. I like what he did, but the chances that I get started and do it is really slim. So one component, in this case, a small contraption, only how many lines? I believe there are 10 lines of code, and you're done. You can have your own speed brake, you made your own custom hardware, your own controller. Logitech would be jealous. They would be like, I want $60 from you. Don't do this because you're gonna... Don't. Go down on the latest update. It's out right now. You could create your own axis commands as well. So for the, I don't know, if you have some special lever with flaps or throttle or whatever that you need an axis for, that is now possible from within the events file. I want to special thanks all the patrons who make this content possible. Without them, these little bastards wouldn't be existing. Now I want to thank all my Patreon supporters who make this content possible, and I put a link in the description on how you can support the channel as well. If you haven't already, don't forget to hit the like button and the subscribe button. And most importantly, I hope to see you in the next one.